Okay.
Good
Good
morning.
morning. We're going to wait for everyone to sign in. I can see people are starting to join us, and we're going to give it a minute or two before we get started. Edie, it's looking like we've got about 31. That number seems to be sticking. So I'm going to go ahead and get started, if that's all right with you. Did you want to say something before we move on?
Go ahead.
Okay. If everyone would go ahead and mute your microphone so we don't get any background noise, I would appreciate that. That way, if your phone goes off, we don't get to listen to that either. Good morning. My name is Ray Ramos. I am the president, senior engineer for Raymond. We've become more of a full service company, but our biggest workload is associated with building envelope, evaluation, design, construction, administration, inspection, testing, whatever the case may be. I've been in the business since 1984, so I'm one of the really old guys in the building envelope environment. Today, what we want to do is we have a presentation that'll last about an hour called Roofs, Walls, Windows Maintenance, and Asset Management. We have a lot of slides to go through, so we're going to move through them. What I'd like you to do is that if you have a question, go ahead and post it in the chat, and Lynn or Edie will interrupt me periodically in order to address your question. So we'll do it that way, and we will go ahead and move forward with this. So just so that you know, those that require AIA certifications, Edie's group will be handling that. You will get a certificate for this presentation worth one AIA credit or a PDH, whichever it is that you may need. Okay, so the course, essentially, I'm just going to go ahead and move to the learning objectives, what we're going to cover here. Essentially, being able to identify the signs of water infiltration, existing building envelope systems, understanding the function of barrier walls, rain screen wall technologies, and how these systems protect the interior environment. Best practices for roof, wall, and window systems maintenance, and then a little bit about asset management and extending the life cycle of building system components. So on our agenda, we'll essentially on roofs, typical things that we've seen through the years for roofs, walls, and windows, and get a little bit into new construction, some of the issues and that you'll face in those types of constructions. Now, we see that is 99% good enough. And we use an example of gold. Gold is typically considered pure at 99.99% purity. But in a roof, as an example, is that really good enough? So, good example. You're looking at a 10 by 10 section of a roof. 99% represents a hole that's about a one foot by 1 foot. And at the purity of gold, 99.99% represents a 1 inch hole. And let me tell you, a lot of water can go through a 1 inch by 1 inch hole. So having a good system that's going to keep the water out is very, very important. So some of the issues that you can encounter with a roofing system, you get into punctures and blisters, and sometimes the blisters may be an issue, sometimes they may not. Manufacturers will tell you if you have a blister and a cap sheet on a mod bit roof, so long as it's not in the lap. They don't get terribly concerned about it because as they see it, it's not letting water into the building. And it could be letting it into the insulation. It has not been detected in the building, but at least it's not being detected in the building, at which time their guarantee may kick in. But you can have little punctures, as you see on the left, that may contribute water over a long period of time, may cause problems, may not cause problems, depending on what's beneath it and what conditions may occur as a result of the entrance of the introduction of water in the system at that location. Vegetation is another issue that you can encounter. On the left, we talk about green roofs. Well, you can get a green roof if you don't maintain it, or if you allow conditions to exist that will allow plant growth to occur on a roof, or in a gutter, as you see on the right, where there's very poor slope in this gutter. Building a round building with a gutter is probably not one of the smartest things in the world to do. And in this particular case, it's actually an interior gutter, which makes it worse. So you can have growth in these when the downspouts clog up, or they don't drain sufficiently where plant life can then enter. We can have animals that decide they want to nest on roofs. And I've seen all types of animals, mice, depending on the type roof it is. Spray polyurethane foam seems to attract mice. Geese and kildees love gravel roofs, and they'll nest up there, poop up there, and can even clog your gutters, which we've had instances of that. Staining is an indicator of a problem. Previously I showed you an interior gutter. Well, here's one of the problems with that system. The downspouts actually in that pilaster and has been leaking for some time, and it's now showing up as staining on the brick below the gutter system. And if you go inside, they have similar problems with staining on that. The gentleman in our company that put together the presentation, I kind of like how he titled this one, and I haven't changed it, Missing Shingles. Actually, this is a school where back in the 90s, when people wanted to get away from low slope roofs, they built shingle roofs. And part of the problem they were encountering was fire ratings of the roof systems on a school. Typically, you put plywood down and you put on a shingle roof, nail it down, and you're good. Well, they were struggling with the UL classifications with shingles at that particular time, and they decided they wanted to eliminate the plywood. And so this particular one's got a metal deck, isocyanurate roof insulation, 2 layers of 1/2-inch sheetrock, and then an underlayment and shingles. And what was happening here is that underneath the deck was conditioned air. That air was getting through the roof system, and we had condensation forming on the underlayment, which then soaked the sheetrock. They had used sheetrock nails in order to hold the shingles, but now they're sliding off the building. So pretty significant failure in this case. So it's a little bit more than missing shingles. And then we can have open flashings where for a variety of reasons, EPDM as an example here tends to shrink over time. And this is a ballasted one. And so it was actually pulling the flashings off of the walls. The owner in this case actually recognized the problem, decided to do a repair, but got a poor contractor who did little more than slice the membrane to allow it to relax. And then to use another piece of EPDM and only caught the edges to hold it in place. So this is what you're seeing as far as a failure in that, and tremendous amount of water getting in the building here. I mentioned that membrane EPDM shrink. Well, all membranes shrink, And depending on the installation, the type system it is and how old it is will determine how much shrinkage. And in this case, it has shrunk so much that what you see in the corner is the through wall scupper and a pump, a sump pump that kicks on when the water gets deep enough so that it can get the water out. And that's how high up the flashings, the shrinkage has resulted in the movement of the through wall scupper. Ice dams. Typically down in the southeast where I am, we don't see this, but this is actually a school in Michigan that was having ice damming problems. And what the big concern here is that in a couple of locations, the ice dams were forming at emergency doors, and they would have to get out there periodically during the wintertime in order to take axes and cut down the icicles that were forming. But this is a case where it's a poorly designed roof system. What you have below is you have a drop ceiling, bad insulation, attic space, a metal deck, a combination OSB and isocyanurate board, felt underlayment, and then a metal panel system. And a couple of problems were associated with this one. If you see the holes through the dormers, those are actually return air louvers. So the space above the ceiling was supposed to be unconditioned air, should be ambient air. The problem with the design, there were several problems, but one problem with the design is that ambient air in the attic space was freezing the sprinkler system. So they put heaters in there and removed some of the bad insulation and kind of made it a hybrid system where it would at least stay warm. But then that heat transferred up through the roof system, melted the snow, and that's what caused the ice damming. And this project, a $3 million claim on this, went to binding arbitration. And unfortunately for the school system, the arbitrator did not give them the $3 million, gave them $375,000. And there was some issues associated with what that was all about, and that's why they got what they got. Ponding. International Building Code, now requires that you have quarter inch per foot slope on new construction. If it's one that was built where it had minimal slope or no slope, they want you to have positive slope, positive drainage, and that can mean a number of different things. Depends on how you want to interpret it and what your structure can handle as far as loads. But ponding is a bad thing, and so we want to make sure that whatever the new design is going to be is going to improve the drainage to the existing drainage facilities. Clogging of drains or drainage systems, gutters, drains, scuppers, whatever the case may be, usually is an indication of poor maintenance. People not getting up on a periodic basis to check their drains and make sure they're clear, their drainage structures are clear. This is actually one that got clogged with goose poop, and as a result led to a building collapse. And I don't know if any of you will ever see this. This is one where we were examining water infiltration through what originally was supposed to be windows. And turns out that we found a much bigger problem, that the water was getting through a very, very porous wall system to the point that it actually backed up in the cavity and came out at grade level, as you can see here. So you can have these kind of problems and not really know about them until somebody does a specific test that can identify what they are. And then we can have collapses, poor drainage, poor structural design. A lot of times, 99% of the time on an existing facility, it's because the drainage system was improperly designed for the structure. I've been on them on new construction where the designer was actually a plumbing contractor, and saw a failure of the roof system. Modifications made to the building where didn't take into account the change in drainage or the amount of water that would now hit these drainage systems, and usually that's why they fail. Had it where you go from literally a flat roof or minimum slope, improve the drainage off the roof, dealt with that, but then found out that the underground drainage system was not capable of handling the faster flows to the drain. So you can have collapses for a number of reasons, and usually it's because of drainage in one form or another. So what do you do when you get on a roof? Whether it's an existing, well, you know, when you're dealing with existing, you want to take a look at what is your drainage conditions? Are they cleaned out? Have they been maintained? Do you have overflow systems? A lot of older buildings do not have overflow systems, and the International Building Code on existing facilities is silent about the addition of secondary drainage on an existing facility. It is a life safety issue, but there is no requirement on the owner's part to install them. However, as designers, we typically recommend that they do. So you get into punctures, again, looking at what can cause a puncture or a defect that allows water to get in. It could be a guy hit by debris, foot traffic that's up there, you know, mechanical contractors, nothing against them, because designers put equipment on the roof, and so people need to get up there to maintain things. And as a result, by working on those roofs can wind up puncturing the membrane depending on the system. And then it's a matter of how you can minimize those punctures by protecting the roof around equipment where they would be working. The membrane itself, you know, old systems don't behave as well as new systems. Installation can affect how the system will behave over the long term. Blistering may or may not be an issue as far as allowing water infiltration. It could result in a premature failure of the cap sheet, but not necessarily be the result of water infiltration. Usually it's just workmanship. And then, like I said, we get into the quality of installation can result in poor seaming of system, particularly on single ply roofs where the seaming operation is critical to the long-term performance of a roof system. Flashings, usually this is where we have the vast majority of our failures of roof systems. Poor installation, inappropriate installation, and with newer systems, not necessarily knowing how the flashings will behave in these new configurations. So securement and installation are absolutely critical, and detecting these problems early on is also critical. Sheet metal. Sheet metal is what basically anchors the edge of the building, edge of the roofs down so that they don't blow off. Poor design, poor attachment of wood blocking, poor attachment of the sheet metal, or not controlling the uplift of the outer flanges of gravel stop fascias and coping. Eventually this stuff will deteriorate and you can have leakage. I've actually seen deterioration of copper as a result of the use of a copper standing roof eroded away as a result of aluminum gravel stop flashings above it. So you can, dissimilar metals, galvanic action can also affect performance of sheet metal.
Right.
Okay. Yes.
Quick question. How far can you extend an SBS modified bit roofing membrane up the backside of a roof parapet utilizing a termination bar?
You know, ideally you want to go about 8 inches, but manufacturers will usually allow you to go about 24 inches. This comes down to workmanship. You know, if you're going to adhere it with asphalt or low rise, I mean, not low rise, but cold process, it's really critical that the applicator knows what he or she is doing. But 24 inches is not uncommon with a termination bar. Any other questions? Okay. Generally on wall systems, you have two basic configurations. On the left, we have a mass wall. We don't see these very much except on the older buildings. If you get closer to the coastlines, you may see these. And essentially, it's a multi-width wall. It can be structural. A lot of times it is structural. And what keeps the water out of the building essentially is the thickness of the wall. The water can penetrate through the mortar joints at the exterior face, but it eventually doesn't have a way to get much further. It can get past the first width, but a lot of times it doesn't. So this is essentially what a mass wall is. Again, older structures, historic property, where they've got brick, this is very likely where you're going to find this particular condition. The vast majority of our systems are a cavity wall system of some sort. You've got a veneer of some sort. Brick is pretty popular. It could be ephes, stucco, glass, siding, whatever the case may be. That's what will be the first thing that you see from the exterior. Once you get past that, then you have a drainage cavity of some sort. It's different. For a brick veneer, it's going to be different from an ephes or a stucco system versus a glass system. May or may not have that type of cavity. And the cavity may actually be in the mullion system of the curtain wall or the glass barrier. But in some form or fashion, there will be a drainage system. And in that drainage system, there will be a means for kicking the water back out to the exterior through wall flashings or flashings that are built into the system that will then direct that water back outside. After that, we can have a variety of interior wall systems. We can have studs, CMU, concrete. I mean, you know, they're all there. What we put on it in that drainage area can be anything from dense glass to plywood. Through the years, it's changed on what goes in there. It can be an insulated wall. It can be uninsulated. We may have sheetrock on the interior. We may have an air barrier or a vapor retarder. So there's a lot of different ways this can go. But the important thing is that we make sure that any water that gets through the exterior veneer has a way for it to get back out before it gets to the interior system. Okay. Now, some of the issues you can face with mass walls. Usually the big one is cracking. And a lot of times it's a case where they did not install control joints through it. And control joints are different than in a veneer system. Typically, this requires that you have structural engineering involved, because now we have to make sure if we're going to put some type of system, particularly in a long massed wall, how are we going to control this cracking and let it crack where it is without compromising the structural integrity of that wall across its length. So these are some of the issues that have to be dealt with, that typically it's going to require some structural engineering in order to deal with those. Now, like I said, most of the time people do not design mass walls anymore because they're so expensive. But if it is designed, these are some of the things that you will encounter. Water will get into these mass walls, and it's going to come back out, and you're going to see it in the form of effervescence. or you're going to see mold or mildew develop in the mortar joints or even on the brick. It just kind of depends. And then the question is whether or not this is causing interior problems or it's just an aesthetic issue. In mass walls that are well constructed, typically it's an aesthetic issue and you may want to come in and clean it periodically. Then we have mortar joint failure. Mortar will fail over time. May require some tuck pointing in order to deal with it. We encounter quite a bit of this work now because some of these buildings are very old and mortar is in a failure mode. And then we have to figure out what type of mortar it is, because the wrong mortar for tuck pointing can actually cause other problems. So, how do we see them? It's usually going to be visual. We'll see efflorescence, as you can see on the upper left, forming on the interior walls. This is a mass wall here, and apparently it was not done very well, where we're getting a significant amount of moisture that has led to the migration of the calcium out of the cements to get to the interior spaces. You can see in the lower left, we got some at the lower level. Sometimes this is the case of poor through-wall flashings, no through-wall flashings, particularly if it's a veneer system, you can have that. The right side, we're dealing with a lack of control joints that has led to this type of cracking at the corners. Also, I'll go back to that slide very quickly. You can see that the comment made about embedded steel. Embedded steel can be the horizontal or the vertical layer that can affect the performance of the brick. You can have a steel column at a corner and a poorly designed brick veneer system that actually they filled. A lot of times you'll see those cavities filled at these corners, and the steel, the difference in thermal expansion, contraction can actually lead to a failure of brick, as you see on the right. Okay, some of the issues you face with mass walls, and you have to be very careful with what you do with mass walls, because they need to dry over time. Water gets into them, it needs to come out. And what we see a lot of times on some of these facilities is, well, we have the effervescence issue, we want to change the look of the building, and so they'll put a coating on it. Want to make it more watertight, want to change what it looks like. And as a result of putting the coating on, we now are trapping moisture in that wall. And depending on where you are in the country will determine the type of failure that can occur. It can be little more than bubbling of your paint, or it can be where the actual finish of the brick starts to spall off because the water will freeze at that coating interface, and over time eventually will cause the brick face to fail. So a little care when you're doing it. Can you cover a brick veneer? A mass wall? Yes, but you have to give it some thought on how that at least one side is going to dry. So if you look at where the interior side of the mass wall parapets, could you cover those? Yes, so long as you have a drying mechanism on the other side, where in this particular case, the brick is uncoated. Okay, so we've talked about the mass wall and where your barrier to water is. Essentially, it's the surface, no coating on it usually. That water just runs along it. Capillary action allows it to come back out during the dry part of the weather, and that's what takes care of it. In the rain screen, the veneer, whatever the case may be, you have that drainage plane, and that water runs down. In this particular case, the inside face of the brick hits your through wall flashing, and gets kicked out through the weeps. So again, a little bit of effervescence. You can see it near the top of the parapet. Usually, particularly with concrete copings, we do see a pretty quick failure of the joints. A lot of times concrete copings are put in with mortar. That mortar separates usually within several years. Water gets through the coping system. And if you don't have a through wall flashing system beneath the coping, then you'll see effervescence forming on the brick below. Some of the other issues, typically we talked about already, failed mortar joints. Getting over time, these mortar joints start to open up. Now, what I will tell you is that this is pretty typical in any application where you're using mortar. Depending on the conditioning of the brick or the stone before application, the dryness of the mortar will determine whether or not you get any movement of the cements to the face of the stone or the brick. So you could have a very dry stone or very dry brick, a very dry mortar, and the cements will not migrate. Or it can be too wet and it doesn't migrate correctly. And as a result, you get open joints like this. But over time, most joints are going to be open to one form or another, one degree of severity or another. And that's why you have a through wall system behind these veneers in order to direct the water back out to the exterior face. Again, some failures, some of it can be structural, a little bit of settlement. This is not uncommon to develop at windows because we have differential movement. The stresses are different at window systems, and depending on how this thing was constructed, you may or may not have these kind of failures. And then typical failure of mortar or sealants at dissimilar systems, brick and metal as an example. Over time, they will fail. It's not if they will, it's when they will. And so these are things that typically require some maintenance, some paying attention to them. Failed gaskets and sealants, not uncommon with window systems, where water, particularly if they don't have a drainage system, the caulks become paramount to the performance of these components. And those that do have drainage systems, and they should be leaking, a lot of times it's because there's not a flashing pan underneath it or was improperly installed. And then the solution is to caulk it all. And we then are dealing with a drainage system that has been intentionally sealed, and the water is going to get worse coming in the building. We can have failed weeps, or we think we have failed weeps. Water's getting in. It could be because they were improperly installed without end dams. The cavity could be filled with mortar or partially filled, which changes the ability of that cavity to drain. Improperly installed weeps can also be a factor to the poor performance. Placement of through wall systems at the wrong locations can also affect performance, which can then lead to water infiltration because we have improperly installed something that allows the water to come through that wall system or through that window system and start showing up on the interior spaces. And then it can, depending on how long you allow this condition to occur, to continue, will determine the extent of the repairs you get to make later. You can see on the left, we're seeing a failure of the wallpaper. The wood is starting to rot. You lift up the wallpaper and you see that we have mold that has developed. Rotting of the wood studs has already started. So by delaying any repairs can actually make the repairs more expensive because the problems have moved farther into the building. What I loved about this particular job is they were having this problem with their windows and wall systems. And their solution to the problem was to use foil-faced duct tape to cover up where the mold was forming on the interior walls, so that the patients didn't know what it was. And that was mold control, which I thought was pretty unique in a way to mitigate your interior mold. So, we covered the different systems, some of the ways that you can have failures where water can get in and cause other problems. And it could be as a result of just the joints have failed, improper repairs, improper installation. Gasket and sealant failures can be wrong materials, poorly installed, not priming, doing the proper priming prior to the application of such sealants. And some of the same things can happen with cavity walls. Usually our biggest problem is the through wall flashings. Sill flashings been properly installed, no indams, no dealing with the joints in those sill flashings, usually are the biggest problems that we encounter. So on new construction, you want to stop here? Questions?
Yes. That was really good on walls and windows, but we had another question come in on roofs. This is from Kimberly. She said, for older roofs, we typically, when replacing roof drains, will add overflow drains to half of the drains and then run them to cow tongues at the face. Do you see this as a good idea, or should we add overflow drains to all?
My opinion, if you don't have overflows, an overflow system of some sort on an existing building, you should strongly encourage your client to do so. It is a life safety issue, because if the primary system backs up, you hope that you have enough structure to handle the water load before it gets off the building. So that's one of the things I always recommend. Now, if you're going to do overflow systems, International Building Code does have certain criteria. The flow rate of the overflow system must be comparable to the primary system. That's number one. Number two, where it exits the building should be at a place where it can be seen, so that if water comes out, people see it, and hopefully they have been educated as to what it means. I was involved in a building collapse years ago where the overflow system on the new addition ran into a conductor and a downspout. And this was located right next to an employee exit. And there was a lot of water coming out of this system. And their solution was to put riprap at the bottom of the downspout so it would not continue to undercut the foundation, not realizing that it was an overflow and that the system was backing up. So that was, that again, a little bit of education is required so that people understand when they see water coming out of these things, should somebody go up there and take a look. Another question?
Nope, we're good now. Thanks, Ray.
Okay, good. All right, let's move on to new construction. So new construction, typically I say, well, you've got to follow International Building Code, and be aware that there have been some changes that can affect roof systems, mostly with wind. And depending on where you are will determine what you have to do to deal with the wind issues. If you now with the code, if you are in a 115 mile an hour zone, you now have to deal with structural issues for wind uplift. So kind of keep that in mind with it. But the new changes that are out there, do your homework. Raymond does a presentation on some of the changes that have occurred within the IBC as they affect roof systems. Also, if you're one of the factory mutual people, There have been some significant changes under Factory Mutual. You need to make sure you are aware, because by not being aware, you're going to submit to Factory Mutual for review and be rejected because you have not incorporated these new changes. So what system are you going to design? What do you want it to look like? How do you want it to perform? Do we have any historic preservation issues that must be resolved before going into design? Drainage, primary and secondary on new construction. No ifs, ands, or buts about it. So you've got to have that. I typically would recommend gutters and downspouts. I know architects don't typically like them. We'll go with drainage systems, internal roof drains and secondary overflow drains. Nothing wrong with those. Scuppers have become an issue because of how you have to size them, but it is a way to deal with drainage. Attachment is critical, particularly when you're dealing with the wind uplift criteria. Manufacturers have standard, but you still need to have an engineer come in and do an uplift analysis to establish wind zones for those particular buildings. Insulation, we're now dealing with R30. I'm sorry. We're now dealing with R30 on new. R15 in some circumstances still applies. Depending on the code will determine what your insulating value needs to be. And then maintenance. Put a lot of equipment up there. There's going to be a lot of maintenance, going to be a lot of traffic. Can the roof system handle that traffic? And if it cannot, you be looking at something else that will assure the long-term performance of that roofing system. So you can have these conditions that occur. This was a perimeter failure. Poor attachment of the wood blocking led to the failure of this roof. In fact, the roofing contractor that was actually replacing the adjacent piece of roof for it blowing off barely got off this roof before it blew off. He literally was on the ladder when this thing came off. So you can have those kind of conditions that can occur. And usually it's for a perimeter problem that results in an uplift. That's typically where it starts. I know this is not new construction, but flashing heights are important. And a lot of times in design, we encounter new designs where we have flashing issues. Not enough height, particularly when you're dealing with curtain walls between the roof level and the bottom of the curtain wall system or the brick veneer system. They didn't take into account the height of the amount of insulation that needs to be installed on the roof. And as a result, we don't have sufficient flashing heights or no flashing heights. We've encountered those problems where we've had to redesign the walls or the through wall flashings were put at a level that resulted in them being behind an expansion joint curve. So these are important things to take into account on new construction. And there are ways you can deal with them. You may have to change the roofing design. Instead of a standard built-up roof or a single-ply roof, you may go with an inverted roof if you have the structure to handle the type system that you're looking to put on them. But ideally, you'd like to have an 8-inch flashing height. Can you go with less? It depends on the manufacturer. Also depends on the flashing system that you use. Using some of the PMMA systems, which are the reinforced 3-course liquid applied systems, they will allow you to go lower because you're dealing with a system that has no seams, no laps. It is homogeneous in its function. And so manufacturers can allow you to go lower under certain conditions. Okay, so, you looked at the old one, the previous photographs where we had flashing height issues. Again, here's one solution where you can go with an upside down roof, PMA, a protective membrane assembly, where the membrane now sits on the deck, works well with structural concrete decks. where you put the membrane, glue it right down. It doesn't work quite as well on metal decks because you have to put some type of cover board or support for that membrane. And then you use an insulation such as extruded polystyrene that is very, very water resistant. You have a drainage system in there. You have a filter fabric, and then you have some overlay of some sort that will go on top. Ballast pavers, it can be green roofing, whatever the case may be. But this system allows you to get the flashing heights that you need if you should have to go that way. But it's a much more expensive system. Then we get into the penetrations and maintenance. Roofs are a great place to put stuff. It's low sloped, but the downside is we now have a lot of flashing work. We have a lot of traffic on such roofs. And so now we get to deal with those issues. And sometime in the future, we get to deal with re-roofing this facility. We're on a VA hospital right now where we have some huge air supply ducts on the roof. And there are two of them stacked on top of each other. They're probably easily 3 to 4 feet on a side in dimension. And we have 18 inches between the existing roof and the bottom of this ductwork. And somehow we've got to go in there and get the contractor to remove that roof and put a new roof on. And on top of that, the ductwork sits right against the wall. So a real challenge when you start putting equipment up there in what it does as far as maintenance, and then having to re-roof sometime in the future. So if you're going to do this, and I've been on towers where, you know, these are really your only options, takes some planning, takes some thought as to what system needs to go up there. Okay, so we can look at just kind of the pros and cons. We won't get into a lot of detail with this. I assume Edie can provide you with these slides in the future, but kind of gives you an idea how you can compare the life cycles of roofs, the pros and cons with systems. As an example, let's look at the EPDMs. The first ones that came out were 45 mils. Pretty standard is now 60 mils. You can go up to 90 mils. Unreinforced, very cheap system to install, particularly if you're doing it in a ballasted configuration where everything is just loose laid and the whole system is held down with rock or pavers. So can be done very inexpensively. But its life cycle, depending on installation, particularly at the seams, will determine how long it gets to last. The shrinkage is an issue that ultimately it starts to pull the flashings off, and you can have flashing failures over time. So usually you're looking at, you can get as little as 10 years. I've seen them go to 30 years if they're well maintained. Let's look at mod bit, usually a 2-ply configuration, a much thicker system because of the 2-ply, usually reinforced. Most would use polyester. You can do fiberglass. You can do a combination of fiberglass and polyester. Kind of depends on what you want, how much you're willing to pay. It's always the case. And there are different ways to put it down, but they're going to be much more expensive than an EPDM or a mechanically fastened TPO or PVC. And so their performance can be much higher. Usually with mod bits, we start seeing blistering because they did not get the base ply dry enough. And so that's usually one of the problems. And then granule loss over time, which then starts to oxidize the cap sheet asphalt that's in there. But they have a long history, and if you take care of them, can do quite well. And the single plies have gotten better too, the TPOs, the PVCs. We lose mill thickness on these. So depending on the thicknesses that you decide to go with will determine how well it's going to perform. If you have a lot of traffic on them, will shorten the life of any system. So again, that's really what you get into with these. Some of the others on steep slope, you can see, you know, asphalt shingles, very cheap to install. You need to make sure, again, with any of these, that there are code issues that you're dealing with. We've seen asphalt shingles that are out there for 30, 40, 50 years. Depending, particularly the newer ones, they seem to be doing quite well. Still comes down to shingle loss, granule loss over time, and then it becomes an aesthetic issue until the flashings start to fail. Wood shakes can work very well, can work very poorly. In high humidity or wet areas, they tend to degrade much faster versus being installed in low humidity areas. They look great, like slate and tile perform very well. Usually with slate and tile, the failure is not so much with that particular material, but it's usually the flashings. Even though you can use copper, 20-ounce copper in your flashing systems, eventually over time, the flashing systems or the underlayment system fails. So you wind up taking them off, putting on new underlayment, new flashings, and you can usually a lot of times reuse those materials with some care, but they're very, very expensive to use. And then we get into the metals. The metals can work well. Metals are one of those, you get one shot at them because a lot of times your fixes are going to require a lot of caulk, and usually that's going to be questionable whether or not it's going to work. The other is going to be the failure of the coating over time. Even a good coating degrades over time. And so now it becomes an aesthetic issue on whether or not you want to keep that up there or try and coat it or do something that will revive its look. And then we get into the coatings that are out there. If you had asked me about coatings as a primary roof system 10 years ago, I would have told you to go take a hike. The systems that are out there now are quite expensive, relatively speaking, but they're very good. And we're starting to see more and more use of three-course systems as the primary roof. And we're also seeing them used where they're applied over an existing roof system. And there are some advantages to that. You have capital cost, tear off and reinstallation. You have code issues. You can put two roofs on, but the third one requires the tear off of both roofs. So you could have a new roof system down there and 15 years later decide that you're going to put on a coating in order to extend the life of it. You put a three-course down and that's not considered a second roof. Now, code may come along at some point and say, you're not going to get away with that. But right now it's considered a maintenance item. And it can be expensed by the owner over 1 year. So there are some advantages to the owner to do a coating system. And if you put a good coating on and the conditions are right for it, what do you do in 10 or 20 years? Some of these coatings are now getting guarantees of 20 years. And so you can then come in 10 or 20 years and put on a new top coat and keep doing that till you reach the economic life of the building. So coatings are becoming interesting in the sense that there are some advantages. You don't have to tear out all that insulation anymore. You don't have to upgrade when you go through this. So owners are taking more of a look at this. And as designers, we need to be prepared for what's happening in that particular industry. You need to be paying attention to it. Okay. I'm going to stop for questions. We seem to be doing good on time.
Oh, good, because we do have a few questions. This one's from Jamie. How many projects, many of the projects shown appear to be older. What are the common issues seen with newer construction aged 15 years or less?
Not knowing what they're doing in design is a big one. You know, they may show a through wall flashing, but located the wrong place is typical. The specs don't include any discussion about end damming, how weeps will be installed, how that system will actually drain water from the cavity to the exterior face. Flashing details, roofing is another one. Usually it's flashing details of some sort. Don't know how to design them. And then the other problem we have is that as a result of the housing collapse in '07, we lost a lot of institutional experience in the construction industry, not only in the design side, but also in the construction side. So we have a lot of new people that are out there that are very poorly trained. Companies haven't taken the time to train them. The people in those companies don't know any better. And so we see some very poor installations. You know, the good companies are always going to be good companies, and they'll continue to perform, although I've seen good companies turn into bad companies. But usually our problem is an improper design, coping system. Everybody likes going to stone systems, but they fail to install a proper flashing system underneath the stone system, thinking that, well, this is going to work well, and there's no way enough water is going to get through it. But I've been on those where I've seen significant failures. I was on one at a city hall. The building is less than 6 years old, and water's getting into the office spaces, around windows, and even at drains. And what we found is that there was nothing wrong with the roof. It was a coping system that was leaking. The water was getting past the roof system onto the concrete deck and traveling to the drains. So we encounter these kind of problems in new construction. They don't know what they're doing, or the designer elects to let the contractor come up with delegated designs. And that then opens it up where the contractor is going to go to the cheapest manufacturer so that his bid is responsive. And those systems may not be appropriate to work. And then the designer is faced with the dilemma, is it acceptable for this job? Because they've opened it up so much that any system can qualify, and it may not work. So those are some of the issues that we encounter on newer construction. Don't know how to set the height on through wall flashings. Hell, they don't know how to set the height on curbs, because they say, well, we want 8-inch curves, but they don't take into account that you've got 5 inches of insulation. And they, instead of saying something like, we want a 8-inch flashing height above the finished roof, when establishing the height of those curves for, let's say, fan units or HVAC curves. So these are some of the things that we encounter all of the time in new construction. Next question.
And I know we've talked internally about how construction administration, having a third party to do that, or plan spec review, is very important for new construction. And Edie reminds me that we've only got a couple minutes left because we're going to 10:15, and we do have several more questions, so we'll get to as many as we can. What is the opinion of TPO fleece back on a mod bit base?
It's acceptable. It's considered a recover is what you do. You have to prep the mod bit properly before you do it, but you can glue it down, and we've done it before. So, substrate preparation is important. You also have to realize that with code on recovers, you must identify where the wet insulation is and remove it before you do such a system, any recover system.
Okay, Edie, do we have time for a couple more questions?
Sure, quickly.
Okay.
Thank you.
Okay, quickly. This one's from Kimberly. What system do you see that most school systems use as their go-to system?
Kind of depends. We have a variety. One of my first clients was 4-ply built up gravel roofs. They're now doing TPO and PVC recovers. We've got another that does 2-ply mod bits and another that does mechanically fastened TPOs or PVCs. So it really depends. And a lot of times this is what's controlling it, particularly in the public sector, is money. 4-ply built up roof is very expensive. And so putting a recover cuts their cost because they're doing minimal amount of tear off. Mechanically fastened TPOs or PVCs or single plies of some sort are relatively expensive to install. Good example, Walmart uses that exclusively on their systems because they put down a 3-inch ISO, a cover board, and mechanically fasten a TPO system. And that they get that, you know, they can get that as cheap as $4 or $5 a square foot. Now, I'm not saying all of you are going to get it because Walmart's a huge entity out there, but it's relatively cheap to do something like that. And more we see in not only the public sector, but in the private sector is going with something that doesn't cost a whole lot to install. And the beauty of a mechanically fastened system is that I put down the insulation in the membrane and 15, 20 years, 25 years later, I come back in, I remove the membrane, leave the insulation, get back up with the current R value, and I can put on another mechanically fastened system. So those are kind of the pros and cons that you encounter with these systems. Next question.
Okay, last question, and we will be quick, Edie. I see that it states that 2/12 slope for standing seam metal roof systems. We typically see these at 4/12. Can you tell us the reasoning that is behind these recommended slopes?
Okay, well, you can actually go as low on a structural standing seam system at 1/4 inch per foot. Okay, so, but you better be careful with that. Now, the reason you want the slope on it is to get the water off the roof as quickly as possible. Metal roof systems, the failure mode is typically the flashings, penetrations through the roofs. Flashings have failed for one reason or another, a lot of times because it was poorly installed, and that's where the water comes in. Also, depending on how long the panels are, will determine the depth of the water by the time it gets to the drainage system, which is typically a gutter and a downspout system. I've seen panels as long as 150 feet, and they have a 1-inch seam. And I can guarantee you that seam is underwater by the time that water gets about 1/3 of the way down the roof during a heavy storm. So that's why you do some of the things that you do with metal systems. Can you go lower? Yes, you can. Well, sounds like I need to wrap up. I really appreciate all of your time. One of the disadvantages of this particular presentation is that it's got over 60 slides and a lot of material to try and cover in an hour. We can give it to you separately. We do these virtual lunch and learns, and we can cover some of the other material if you would like to attend those. But I do appreciate your time. Very good questions today. I hope you have learned something, that building envelope is not as easy as we all thought it was when we got into it. So if there are no other issues, thank you for your time and have a good conference.